Thank you very much. We're still a couple of minutes before the official starting time, so I wanted to say that I'm here to talk about intake, obviously, but if you have questions about Anaconda, the software, or Anaconda, the company, or Dask, the other main open source project that I'm involved in, then please come talk to me, and I'll be as forthcoming as I can possibly manage. But today I'm talking about intake, so intake is new, and the reason that I'm going to these conferences is to show you a little bit about what intake is about, so give you a feel for where it fits in. But what I really want is for people to use it, install it, use it, give your feedback. It's so new that people's opinions are important. We can decide where we're going to go from the current state of the software. All opinions welcome, in person, on GitHub. However, there's a Gitter channel too, so please try it. Tell me what you think. OK, so getting started. We're talking about data. Who here has written code that looks something like this? Does this look familiar? To a reasonable fraction of the people. Those that have had their coffee anyway, yeah? What this code cell does is access a number of files, which in this case happens to be on an HTTP server. It's a totally reasonable thing you might face. It uses pandas to load them, and the very last line here, it creates a data frame out of the data. This is usually a preliminary step that a data scientist, analyst, whatever, has to go through in order to get the thing that they actually want to use for their work, in this case, a data frame. So CSVs are very common, pandas is very popular, data frames are pretty ubiquitous in data analysis. This kind of code exists in various forms all over the place. Now, the various people who will interact with something like this will have different opinions on a code cell that looks like this. So I'm going to take you through a few viewpoints on this code cell. First of all, there's the person that I'm going to call the data user. This is the person that actually is executing this cell because they want the data frame, and they want to then analyze it and actually do their job, which is to make insights from that data. I just want to mention, this is a data frame. It could be more or less anything. There's lots of times you want to get data from somewhere into a form that you can then analyze. It's just an example. So the data user doesn't want to have to do this every time. They don't want to have to figure out, hey, which files am I supposed to be loading here? What do I have to do to actually get those files? How do I load them? How do I stitch them together? This is really annoying. So, question, do I have to do this every time? And in fact, all that I know about this data when I come back to this script or notebook later is, oh, it's called part 1, part 2. I don't even know what that is anymore. So you need a way of understanding something about your data. Is this actually the right stuff that you need for your job? Secondly, there'll be somebody I'll call the data provider. This is the person that has made this data available to the company or institution. They've actually put these files in a location, and there they might think, for example, oh, somebody's accessed these files, but actually that's not the current best version. There's a new one. You should have been using that. And in fact, the new version is now in a different format. It's in a different storage mechanism. You can't use this code anymore. Not only do they need to make sure that the user knows this, but now they actually have to instruct the user. How do you go about getting the new form of this data? Thirdly, there's the IT department. For those of you that are at corporations, you very likely have one of these, or at a government institute. You're not supposed to do this, right? I've put a little thing in here. Oh, I'm going to access this data with my own secret credentials. You're not supposed to do that, right? You never put secret information into your code, because that code will get passed around. And in fact, maybe this wasn't your code. Maybe you just copied and pasted it from elsewhere, and now you're just using credentials that don't belong to you. You don't know where they come from, and the system that is monitoring who accesses what will think it's the wrong person. That's a big problem. And finally, there is somebody who is a coder, which at a conference like this might be many of you. There's a new format of this data. Oh, you want a data frame out of it, but actually that code doesn't even exist yet. So this person will have to write some code to do that initial import of the data. That's really annoying, especially if it's stored on a different backend. So at some point, somebody's going to have to make code to make this data available to the user. In intake, this is the big reveal. This is the slide that's supposed to impress you. You can do this. You can say, I have a catalog somewhere. In this case, it's a file. I'll talk to you more about what a catalog actually means shortly. In there is a specification of what the data is, how it needs to be loaded, maybe stuff about credentials, all of the things that you need to be able to access the data. All the user has to do is do .read at the end of it, and that's it. This is obviously much simpler for the user, but it actually solves many of the other problems that I mentioned as well. So to go over in a slightly more detail of these personas, there is the data user. I already mentioned these questions they may have, so I won't go over that again. This, by the way, is what Google Images thinks that a data scientist looks like, in case you're wondering. I'm sure those data scientists amongst you do these geometric things all the time, right? So for the intake perspective, you have the CodeCell, as before. You have the nice GUI that I will show you shortly. But you have more than that. You have the ability to get information about each of these data sets. You can search your catalog so that you can figure out which of your data sets is actually the one that you want to be using. There's also quick plots and, of course, one-line loading of the data. That is the kind of point of intake. From the data provider point of view, so now you have a mechanism of pushing your specification of what the data is to the user. All that the user needs to know is where is the catalog or have some means of accessing the catalog, and the job is done. You don't need to instruct them. You don't need to inform them of updates, because you can put this in a place where you just change the catalog. Now it's updated. They don't need to do anything special. Also, it will be your reference for the data inventory itself. So the creator of data artifacts, the person who is in charge of maintaining the data catalog, has a natural place to do that, given intake. And it looks a bit like this. So this is the simplest version, YAML prescription. It's not the only way that you can create a catalog, but it is the simplest way. And it looks something like this. This is maybe a bit small for you, but this thing describes just a single data set, which I've just called entry one part, because it has parts to it. It has some description. It has a driver. The driver is code that I'll show you shortly. It may have some parameters for the user to have their own choices when they load this data. This will show up for the user. Hey, you have these choices. You can choose one or two in this case. It will have arbitrary metadata associated with it. This is how the user can know what this data is. They can search on this metadata. Thirdly, there's IT. I won't talk much about this because I assume we don't have many IT department people here, but IT cares about who has access to what. They care about access control like that. They care about who has accessed one, so the monitoring of the system. So they want to be in charge of the authentication. They want to also possibly be the gatekeepers of what data gets into the system. And here is another version of a YAML catalog. In this case, we have some access control in here. You can see if this were a location on S3 and you require username and password to access it, you can template these. You can either get this information directly from the user if it's supposed to be something that is not held in a credentials database. You can get it from the environment as a default if the user does not supply a value, or other mechanisms. It's actually pretty open. Everything in intake is meant to be pluggable so that you can come up with your own ways of doing these things. And finally, the developer. Again, this is Google's idea of what a developer looks like. I'm sure all of you look exactly like this. Developer doesn't want to be rewriting similar code time and time again to do the same job. You want to reuse libraries as much as possible. You want to be within a logical framework so that you can present the same API to the user so that you don't have to instruct the user, all those good things. You don't want to have to put your code into some big package like pandas. If you have a new way to load pandas, you don't want to have to wait for pandas to go through a review cycle and release, right? You want a thing that's going to sit by itself. So intake fits in quite nicely with this. Here is an intake data driver. It's complete. It uses a third-party library that already existed, so part of the job was done. All this really is a thin layer on top of that basically, well, you can't read the code, that's fine. The point is that in this particular case, this is viewing some HTTP API as a data source. It happens to be GitHub issues. So you can use this code now to say, this is a data set which happens to be all of the GitHub issues that belong to this particular project. In intake, you have a lot of flexibility to do all manner of data, not just files, not just data services like SQL, but arbitrary data sources like this. And it gives you a framework within which to write these drivers that is simple and straightforward. From the user's point of view, it looks exactly the same every time. Now I have some examples, and there has not been much live code in this conference, so let's try this out. The first one, I'm calling this a data science workflow because lots of people will be data scientists here, I suppose. This is the user of the code. And you can, using intake, enable something like this. I hope you can read that. This says conda install data. So this is, I assume lots of you know what conda is. It's a package management system. Using conda, you can now install data catalogs. You can install the files themselves. More likely, you're just installing the prescription of how to get that data. From the user's point of view, they just conda install. It's versioned so that you can push updates. Dependencies are met, so the user doesn't need to install any extra stuff. It's very handy. Now we have this intake.cat is all of the things that I've installed. It's just a single one here. You can get information about it. Like so. It has a basic description. We know it's going to be a data frame. You can get more detailed information about it. So this is all of the D types associated with it. We don't need to go into the details too much. You may have some plots predefined as part of the data specification. So here is one that's showing the robbery and burglary rate in the US as a function of time. So apparently 1981 was a particularly bad time to have valuables in your house for some reason. I don't know why. I'm not a scientist of that. And you can get the data, and then this is now just a data frame, and you can do all the good data frame-like things that you may want to do with it. This is the most common thing that a data scientist will actually do. So I won't go into any of the pandas stuff, but I will show you the GUI that I alluded to briefly before. This is, again, it's just showing me the one installed data set. And once I've selected it, I don't have to reference it by name anymore. I can just reference this thing called item and use it the same way. Or I can add more catalogs into here. This can be done automatically. So let me find this is just a file browser on my local system, so I have lots of things here. And I will find you one of my examples. OK, and now it's here. And it has a load of entries. I can go through these entries. Again, I can get basic description. Included in here is one that is actually another catalog. So this is a hierarchical thing. You can have a master catalog that points to lots of other catalogs. These catalogs do not necessarily have to be local. So I'll also demonstrate this. If the conference Wi-Fi works, then I'll be able to access this. Spinner. This is now a catalog prescription that exists elsewhere. So you can see I use the HTTP link here. You can have a, looks like the Wi-Fi is not going to work for me. This, I'll tell you quite interestingly, is the Pangeo collaboration. Pangeo is a scientist org. Oh, yeah, connection timed out. Sorry, Wi-Fi's bad. And they use Intake as a way of referencing all of the data that they have within their online system. It's all cloud-based, and it makes sense if you have a cloud-based data system that you would have a catalog that is also accessible online so that you can just reference this catalog and you can get the data. Okay, the second example, so this is a pretty short talk. I'll try and get through this quite quickly. So this is doing something simple, but from the other side. Now we're the provider of the data. Intake comes with a certain number of built-in drivers, but you could make your own, as the one I demonstrated on the slide before. I won't go through that now. But how would you actually go about making the catalog? So you would normally start with something like this. Let's see if I can access this. The point here is that in the functions that you use with Intake, normally, Wi-Fi is on and working, but nothing is okay. Usually when you think of accessing files, you think about accessing local files. Intake is designed so that you can access files remotely and access multiple files, and the stitching is done automatically for you. Yeah, so the internet is not working for me, so I can't demonstrate everything that I wanted to, which is unfortunate. If you have a connection, then you can access remote data quite well. And the point of doing this is that the things that you put in here, the arguments, are exactly the same arguments as you need to encode into a catalog. So once you've done that, so I won't show this because nothing will work here, you can make your own plots, and you can get a YAML prescription automatically of the data source that you wanted to view. Once you've done that, you get a minimalist YAML. You can just put that into a file where the arguments here will be automatically filled in from the arguments you used to create this data source. You add your own description. You can add in some plots if you want to, any other arbitrary metadata. This is now a catalog. Anybody can access this. So you could say to your data user, hey, there's this new catalog file. Why don't you load it? And it will have exactly the same functionality as the original CSV source. So job done, right? You can put this YAML file into a place where everybody can access it. This example would be on GitHub. Everybody has right permission to GitHub. You can make a gist or a repo, put your files in there, point people at the files, and your job is done. The other route, as I alluded to in the other presentation, in the other notebook, would be to put this into a Conda package, also easy to do. So now you have many routes of authoring a prescription that's going to be a data set for the end user to use. They don't need to know anything about what this data, how you actually go about loading it. All they need is the descriptive stuff to know that they have the right data in front of them. Okay, so most of my time I'm hoping to have questions, so I will go just quickly to the end. First, I'll say that please go to the documentation. So on ReadDocs, this is the current set of data drivers that exist. So you'll notice many of these are files, but many more of them are actually data services, things like Accumulo or whatever. There's quite a few of these. This is now out of date. There are more coming. Make your requests known, what data is most important to you. Have a go at writing those things if you want to. If there's a Python library that exists that already deals with some data, getting that thing into the intake system is really simple. Intake's aim is to be very simple code that anybody can read and add to. It's very pluggable. You can add new functionality really easily. It interacts well with the rest of the Python data ecosystem. If you recognize some of these different icons down here, it interacts well with cloud-based data storage if you have a working network. such as S3 or whatever. So all of these things should come automatically and transparently. It comes with other features and goodies that I don't have time to go into, but you can ask me about later or read the documentation. But really what I want from this audience is for people to try it. So we have lots of time for discussion. Questions? Please.
Questions for Martin? The range of the mic is not too great.
Hello. Hi, thank you for the great talk. I have one question. So a basic pain point is not really to write the code, but to write the code in some efficient manner. Like I can always write a stupid iterator which would just pick everything and still get me a converter to say. But so intake would have certain transformers basically between different data sources which would be inbuilt into the library, right? And then others can kind of extend it by using their own custom functions. But the ones which would be within intake, is there any emphasis on making them highly performant and something along those lines?
Performance is always a thorny question, obviously. Intake calls other libraries to do its work. So if you think that pandas is efficient, then intake is efficient. Intake does interact with Dask for those people that know what Dask is. I encourage you to try it out if you don't. So many of the data types can also be loaded directly with Dask. So then you get out-of-core performance, and you get out-of-core. I mean that you don't have to have the whole data set in memory at one go in order to be able to process it. But you also get multi-core or distributed computing if you want that, if that's appropriate for your use case. There will also be hooks to Spark, which don't exist yet, but are on their way. So that is also performance, if that's what you need. So again, intake doesn't really implement the low-level logic of turning some byte into some in-memory representation. It's a layer of other things that do that. So it's going to depend on those libraries, usually.
Does intake attempt to address ETL as well, or is it just more to kind of bind everything up in a nice way together?
The question was, does intake do ETL? And the answer is it can. Typically, intake wants to be the layer that is get your data into a common representation like an array or a data frame so that you can do your science with it. So to keep it nice and general, and then you can make a driver that is useful to lots of people. But you can embed as much logic into these drivers as is right for your situation. So you could write something that doesn't just, this was a CSV to data frame, you could have a particular type of CSV that you understand well beforehand that you're going to want to do a few stages to before you call the output product a finished thing that's ready for analysis. You could have a driver that does that. And in fact, you can have drivers whose input is the output of other drivers. So you could piggyback on the CSV one that outputs a data frame, and then have another driver that takes that data frame as input and does something to it, and now you have another data set as output. Those things are possible. Whether you want to write that kind of logic will depend on what your situation is.
Hi, you said something about a set of Spark hooks. Could you elaborate on that a little bit more? Specifically, I'm thinking in terms of something what Hive Catalog offers, where in your Spark SQL, you can just refer to the Hive Catalog item, and it'll expand it to whatever the S3 link is automatically internally. Mm-hmm. Is that the kind of thing you were talking about?
So yes, exactly. A library like PySpark already has many data loading methods, as does Pandas, as does Xarray, for example, another project that I'm involved in. And this is part of the problem, that if you know that you want to deal with a Spark data frame exclusively, then you're probably going to be using those methods at the moment, and you have some concept of some named things. But actually, data is far more ubiquitous than that. It has lots of different forms, and you probably want to access it in lots of different areas. So intake aims to be a bridge over all of these different things. Not only will it be able to load from some files, as the example is here, but it will be able to take definitions of data sources from other catalog-like things and present them in a unified way to the user. For the Spark case, all it will really do is call the exact same Spark named thing.load or .read or whatever it is, and give you back a Spark object with which you can do normal Spark things. So it won't be a huge amount of functionality in that sense, but it will bring what Spark can already do into the intake space so that it can sit alongside other data sets that you have.
More questions? Yeah. You can just ask me.
Curious if what the vision is for intake to take advantage or not take advantage of server-side features for the underlying data store. So like where it's not a file, things like server-side casting or server-side joins with other tables. Do you plan on taking advantage of those things, or is that going to be left out of the API?
So it depends on the specific code that's going to talk to that data service. For joins, for example, if you have a traditional SQL database, then you can do this now. You can submit a query that gives you back data. That query is anything that you want. So if you have complex joins that you want your database system to take care of for you and give you some aggregated data, and that's the thing that you view as a data source in itself, that's fine. You can do that. And the same will go for that. There are lots of data services that are like that. So we have Elasticsearch, for example, also allows you to do very complex queries, but the thing that intake sends to the server is the whole query. So if you make it a simple query and you want to work on it in the notebook or on whatever distributed computing system you happen to have set up to deal with that, that's fine. Or if you want to push it to the server, then you write a more complex query and the server takes care of it. So those are all possibilities.
Any more questions? Well, I have a question if there's no more questions. There's a recent trend of search engines for data, right? Like Google has a data set search engine. So is there some way to translate that information returned by those data set search engines into these YAML manifests, your catalogs, so that we can directly then use it in our Pandas notebook?
The answer is yes. And we are actively pursuing that. I mentioned the Pangeo collaboration. There is likely to be exactly what you're talking about for the NASA data archive, Earth Science Data Archive, which is a massive queryable service. So not quite like Google, but a similar idea. So you can submit a query to this service. It gives you back data resources. You can so the code will interpret those, and they will appear as catalog entries to the user. So we already have one driver that does this for the SQL Server case, in which case you're just getting named tables. So a normal traditional SQL system will have some number of named tables. This driver takes that set of table names and presents them as data entries to the user. So in this case, we know, of course, from a SQL Server what data types they will have. All those things are already included. And you don't need an intermediate YAML representation at all to do that.
All right, more questions? We still have, yeah, go ahead.
The original problem you described with the user passwords and notebooks is something that I was explaining as well. I'm curious, like, the actual, like, how does Intake actually solve that problem? It sounded like you had some templated user password variables in the catalog files, but can you just elaborate a bit more on how that works?
So the question was to give more detail on the possibility of using intake to fill in sensitive data, or in fact, I'll add to that arbitrary data. Intake has a user parameter system by which you can substitute values into any of the arguments that you're going to pass to your driver. So if the driver takes username, password as inputs, then you can substitute the values of those using what we're calling user parameters. Those user parameters in turn can have default values which are taken from the environment or taken from some bash command, anything actually, or some logic, some code somewhere. So there's lots of ways that you can fill in how do you fetch the default value for that. And that is what the environment variable is probably going to be the most common, because that's something that's already in use in most systems. So the system administrator makes available some environment variables. If the user doesn't supply their own input for these user parameters, then they will be substituted from the environment and passed to the backend driver, and that completes the circle. It could, and we have a system for doing this that's just prototype. It could interact with a full authentication system, JWT or whatever it is. So we have a proof of concept of that too. And finally, if you are interested, Intake also comes with a server component. So you can actually put your data specifications and the data itself, if you want, behind a gate, and you can have full control over how users access that gate. So maybe they need indeed a JWT or some kind of credential to be able to get the specifications, and then you can gatekeep on the data as well if you want to. So that's where the IT part of this comes in.
All right, let's thank the speaker once again. Thank you.